Hello, everyone, and welcome to Space News. I'm your host, Nico DeMarinis,
And I'm your co-host, Kieran Gill.
and in today's episode, we're going to be covering SpaceX's SN11 and SN15 launches, another Starlink mission from SpaceX, and SpaceX moon contract with NASA. We will also be covering NASA's testing the SLS engine for the James Webb Telescope flight, and we'll also be talking about Ingenuity's flight on Mars and the Muon G-2 experiment. These past weeks have been loaded with crazy space news. So, Kieran, why don't you take it away?
Thanks, Nico. Just as he was saying, these past few weeks have been loaded with new space news. The first story that I'm going to mention is the cover of SN15's recent rollout. Now, for those of you that don't know what the SN15 is, it's a full-scale Starship prototype that has a lot of improvements over the last iteration SN11, which unfortunately we saw explode a few weeks ago. Most of the improvements are in the 3 Raptor engines in the Starship used to propel itself upwards, where they completely redesigned the thrust puck, which is at the bottom of the thrust dome. Now with the SN15 on the suborbital launch pad A, SpaceX will be carrying out a cryo test and a static fire. So Nico, would you like to explain those two things?
Yeah, totally. So, a cryo test is something that SpaceX does before all of its launches, and it essentially tests the vehicle's sustainability to freezing cold temperatures. SpaceX uses a very cold propellant called liquid oxygen, and liquid oxygen needs to be kept at extremely cold temperatures to ensure that it can be used by the SN15. So they need to conduct this test to make sure that the vehicle can hold such cold propellant. They also need to conduct a static fire, which occurs when they only fill up the propellant tanks with just a little bit of propellant so that they can test the engines to make sure everything's working before they go for a full launch.
Yep, and so now they aim to launch the SN15 in the coming weeks. SpaceX plans to continue its prototypes all the way up to SN20, which will be an orbit-capable ship. SpaceX also had yet another successful Starlink mission, deploying 60 satellites, which will one day provide internet capabilities to even the most remote places on Earth. Also with the Starlink mission, SpaceX had its first uninterrupted video broadcast, which was interesting to see on the Falcon 9 landing on the drone ship named Of Course I Still Love You. It was rumored that they were using Starlink satellites to pull this off. Also, a big congratulations to SpaceX for being chosen by NASA to provide transportation to the moon in 2024. SpaceX plans to use a specifically designed Starship on top of the Super Heavy booster to put astronauts back on the moon since the 70s. We always love to see that fan favorite win. Now, as fascinating as SpaceX is, it's time to move on to some other space news. Nico, why don't you take it away?
Yes, so this was also a really big week for NASA. They first tested the RS-25 SLS engine for over 500 seconds with no issues whatsoever. Now, this will be the engine launching the Space Launch System and, more importantly, the James Webb Telescope out of Earth's atmosphere and into the Lagrange point 2. For those of you who don't know what a Lagrange point is, here's Kieran to explain it.
Yeah, so basically, the Lagrange point is essentially a place in our solar system where all the forces of gravity from all of the planets and the sun just cancel each other out. There are 5 of these kinds of places in our solar system, and as Nico said, the James Webb Telescope is going to L2.
Thank you, Kieran. Also, the NASA Dragon crew was seen performing a successful redocking of the Dragon capsule on the ISS to make room for Dragon Crew 2, who will launch this Thursday from Cape Canaveral on top of the Falcon 9 rocket. So make sure you wake up early on Thursday morning because they'll be launching at 6:11 a.m. Eastern Time. Now, one final monumental piece of news pertaining to Mars and flight is Ingenuity becoming the first spacecraft to ever fly on another planet. For those who don't know what Ingenuity is, it is a small helicopter-like spacecraft that was dropped off by the Perseverance rover earlier this week. NASA reported that this spacecraft flew for about 40 seconds, proving that flight is possible on the red planet. Now, to take a bit of a turn from the space news and move to a little bit of more physics news, earlier this month, Fermilab announced its muon G-2 experiment and the findings that came with it. Now, I know you've all been eagerly waiting to hear about what the findings were, so I'll jump right into it. Fermilab found that we know even less about particle physics than we previously thought. Well, what they actually found was that a muon behaved a little differently than what was expected when measuring the muon's wobble. Now, you may be wondering, what is a muon? Muons are particles in our universe that are essentially heavy electrons. There are many particles in our universe that don't get the same amount of recognition as the electron and proton. And, some examples are the Higgs boson, the neutrino, and the muon. And as I mentioned before, a muon is essentially just a heavy electron, and it was discovered in 1936. For this experiment, they were looking at the muon's spin factor, or more specifically, the G factor. All particles have a spin factor, and the muon has been measured to be around 2. Now, that's not perfect because there's a phenomenon known as quantum fluctuations, or quantum foam, where virtual particles are constantly being created and destroyed in empty space. So, to account for this, it's around 2.0023183620 for the actual spin factor of a muon. Now, what they found in the experiment was actually not that number that the theory predicted, or that the standard model predicted. What they found was that it actually differed in the last 4 digits of that spin factor. Instead of 3620, it was 4122. So this was a difference of around 4.2 standard deviations, which is significantly off in the realm of particle physics when you're dealing with such minute measurements. But unfortunately, this was not a big enough standard deviation to be called a major scientific finding. So, for a scientific finding to be considered a large one, you need 5 standard deviations. But regardless, it is still a monumental discovery for the team at Fermilab and for all physics. Now, Kieran, did you have any questions about the muon G-2 experiment?
Not about the experiment, actually. I wanted to go back to the Ingenuity.
Mm-hmm.
It was actually pretty interesting to hear about flying and how, we're having something fly on a planet that's not Earth for the first time ever, which is absolutely insane.
Yeah, that happened on Monday, and I was absolutely thrilled to see it pop up on my phone that they had a successful flight, because obviously they were unable to test anything on the planet, so they had to all predict what the air quality or what all the different factors were going to be. And if they didn't predict for some sort of wind, that $1 million drone that they set off would have gone flying into the dirt, and it would have been a wasted experiment. So I'm very glad to see that everything worked out for them.
Yeah, crazy stuff. That's going to be all from us this time on the Space News Podcast. Thanks for listening. Be sure to catch us next time. And with that being said, that's the end of our show.
Yep. Thanks again for tuning in, and always remember to look up. Bye-bye.
Bye.